In example 8, we've got a situation where we have to use logarithmic differentiation. Anytime you've got a variable in the exponent, if it's not e to the x, that's your exception. But anytime you have a variable in the exponent, you have to use logarithmic differentiation. You can't do the power rule when there's a variable up there. And remember, your steps for logarithmic differentiation are going to be take natural log of both sides, simplify the problem with log rules, find the derivative, and then solve for y prime. So what we're going to do is first take the natural log of both sides. Sorry, I'll use the other end of the marker. And then we want to simplify using log rules. And here I've got an exponent, so I can move that in front. So that would just leave natural log x now. And now it's ready to find the derivative. So I did step 1, natural log of both sides. Step 2, use log rules. Step 3, find the derivative of each side. So derivative of y, or natural log of y is 1 over y. And then we're doing implicit differentiation, so we get y prime. This is a product rule. So we're going to leave radical x alone, then do natural log of the second part. So natural log of x is 1 over x, plus we leave the second part alone and do derivative of the first part. Remember, square root of x is x to the 1/2, so this will be 1/2 x to the negative 1/2. And then, so we've got our derivative. Now we want to simplify what we can, and we want to solve for y prime. So I guess I would change these into fractions. So I've got natural log x on top, and then I've got a 1/2, so there's a 2 on the bottom, and this is a negative exponent, so square root x on the bottom. For me, I would get common denominators, so if I multiply this side by 2, so this is a 2x, I can make this a 2x if I give this an extra radical, because rad x times rad x is x. So now I've got 2 rad x plus natural log x radical x, and just that x is in the natural log, all over 2x. That's as simplified as I can get that. And then you want to multiply both sides by y, because remember our next step is to get y prime by itself. So I've got y prime equals y times all of that. And if it's possible to get y by itself in the original function, then you want to substitute it back in at the end because you don't want to have a y in your answer. So we go back up to the original, and y is x radical x, and you substitute that in for the y value. So that'll be y prime is x rad x, and then that whole parentheses that we already did. And that is your derivative.